Okay, today we're looking at something called formula mass and percent composition. And the question that we're going to use this to answer, one of them, is this one. What is the molar mass of a compound? Let's take a compound that we're pretty familiar with, our old buddy water. And it's a molecular compound. Molecular ionic doesn't really matter. What we do know is that in this formula there are 2 atoms of hydrogen and 1 atom of oxygen, if there's no subscript after the element, then it just means 1. And we know, going all the way back to the very beginning, chapter 3, that hydrogen has a atomic mass of 1.008 grams. We remember that this is both the atomic mass and it's also the molar mass, meaning it's the mass of 1 mole. And we also know that oxygen has an atomic mass of 15.99. Let's make this easy on ourselves. We're going to round these to the nearest whole number. That's going to make things a lot easier. So when we're asking what is the molar mass of a compound, we're adding up the atomic masses or formula masses or molar masses, whatever you want to call them, of every element in this compound. So making this a lot more drawn out than it needs to be, what's the molar mass of our old buddy water? Well, we know that we have 2 atoms of hydrogen and they're each 1 gram, and we have 1 atom of oxygen and they're each 16 grams for a total of 18 grams. And that is all you do. Let's try a bigger one and we'll go a little bit faster this time. So here is our old buddy table salt, and if I was going to ask you to calculate the molar mass of table salt, otherwise known as sodium chloride, you'd want the molar masses of both elements involved. So looking at our periodic table, we know that sodium has a molar mass of 22.99. We're going to round that to 23, and that chlorine has a mass of 35.453. Now, this one can present some difficulties. How are you going to round this? You're going to round this to 35. You're going to round this to 36. The answer is that both of these are perfectly correct. Some of you are going to round this down to 35. And some of you are going to round this up to 36. Either one is acceptable. So if I was going to ask you to calculate the formula mass for sodium chloride, you would say that we have 1 sodium atom with a mass of 23 grams plus 1 chlorine atom. And if you rounded it to 35, you would get a molar mass of 58 grams. And that is correct. If you were going to round that to 36 grams, you would get a molar mass of 59 grams, and that is also correct. That's up to you. So how are we going to use this? Well, the first thing that we're going to use it as is a conversion factor. Let me give you an example of what we mean by a conversion factor. And here is a typical question you can expect me to ask you. So here's a question you could expect me to ask you. What mass of iron 3 hydroxide is 5 moles of iron 3 hydroxide? So we're going to need a formula, and iron 3 hydroxide looks like this. We've got 1 iron and we've got 3 hydroxides. And of course, each hydroxide has 1 oxygen and 1 hydrogen. So what's our molar mass? And looking at our periodic table, we know that iron has a molar mass of 55.8 grams. I'm going to round that to 56. We know that oxygen has a molar mass of 16 grams and hydrogen is 1 gram. So what's our molar mass? A couple ways you could do this. We could say that we have 1 iron, and of course that's 56 grams, and we have 3 hydroxides, and of course they're each 17 grams. So what's our total molar mass? 56 plus 3 times 17, which, turning on my mental calculator here, is 51 grams, and of course that means that our overall molar mass of iron 3 hydroxide is 107. So now that we know our molar mass,
This is Montia. The main office, please. Montia.
well, now that we know our molar mass, we can set up our conversion, and we're going to say how many grams, because the question is asking for mass, right? What mass of iron 3 hydroxide? How many grams of iron 3 hydroxide is the equivalent of 5 moles? And because we know that 1 mole of iron 3 hydroxide is 107 grams, how many moles is this? And of course we set this up, moles cancel, leaves our answer in grams, and we get Now be careful, because I might ask you to calculate molecules as well, and let's remember that 1 mole of anything is equal to 6.02 times 10 to the 23rd of that thing. Just keep that number in mind if I ask for it. The second way we're going to use this is something called percent composition, and this is going to ask the following question. What is the percentage by mass of each element in a compound? In the previous examples, we said that water has a formula mass of 18 grams. Sodium chloride, depending on how you round it, has a formula mass of 59 grams. And iron 3 hydroxide has a formula mass of 107 grams. So what is the percentage by mass of each element? Here's what we mean. Let's take our buddy water. So we know that water has a molar mass of 18 grams. We want to ask what percentage of that 18 grams is hydrogen, and what percentage of that 18 grams is oxygen. So here's how we do that. If we know the molar mass is 18 grams, what mass of that is hydrogen? We know we have 2 hydrogens and they're each 1 gram, so that's a total of 2 grams. What percentage of hydrogen is 2 grams of our total 18? We're simply going to divide 2 grams by 18 and we'll multiply by 100. If we do that, we get 11.1% hydrogen. Let's do the same thing with our oxygen. We have 1 oxygen and it is 16 grams. So what percentage of our total mass of 18 is oxygen? We're going to say, well, 16 grams divided by 18, and then we'll multiply it by 100 to get it into a percentage, and we should get 88.9% oxygen. We should, if we did this right, be able to add these percentages up and get 100. Because we're rounding, sometimes they'll be a little weird, but they should be close. Since we're rounding, all we care about is close. Let's try this iron 3 hydroxide stuff and see what we get with that one. So in iron 3 hydroxide, we know the molar mass is 107 grams. We want to ask what percentage of this is iron, what percentage of this mass is oxygen, and what percentage of this mass is hydrogen. So if we know that, for example, iron has a mass of 56 grams, what percentage of 107 is iron? We're going to say 56 grams divided by 107 grams. We'll multiply it by 100 to get it into a percentage, and we get 52.3% iron by mass. Let's do the same thing with our oxygen. Now be careful, because we have a subscript that was supposed to be highlighter. We have a subscript of 3. That means that we have 3 oxygens. And so if there are 3 oxygens and each of them is 16 grams, that means that the mass of oxygen is 48 grams. What percentage of 107 grams is our oxygen? We're going to take 48 and divide it by our total mass, 107, and we get 44.9% oxygen. Lastly, what is our mass of hydrogen? Well, we've got this, subscript of 3, and it's pertaining to this whole series of elements in this parentheses. That means that we have 3 hydrogens. Well, that's easy because they're each 1 gram. So what percentage of our total mass is 3 grams? Let's plug that into our calculator. And remember, we're going to multiply this by 100 to get it into a percentage. So we plug it into our calculator and we get 2.8% hydrogen by mass. If you want to do a quick check to make sure you did this right, you can add these up to see how close you got to 100. And remember, because that we're rounding, it might not always add up, but in this case, it does. And so that's all we do. That's how you do percent composition. Okay? Take it for a spin.